Good morning, students. Today we are going to read the second lecture in the topic of redox reaction in the subject of chemistry O levels. So concentrate yourself in this lecture too. We will read today some common oxidizing agents and some common reducing agents and some everyday oxidizing and reducing agents and half equations, and we will solve some important questions from the past paper and from the book as well. So concentrate yourself. We are going to start. The first topic is common oxidizing agent. So acidified potassium manganate is very common oxidizing agent. Half equation is this: MnO4 plus 8H plus 5 electrons forms Mn2 plus 4H2O. These half equations you have to learn because they come paper. They usually come in the paper. Okay, its color, when color change when added to reducing agent, its color change from purple to pale pink. Okay, the second common oxidizing agent is acidified potassium dichromate. Half equation is Cr2O7 2 minus plus 4H plus 6 electrons form 2Cr3 plus 7H2O, and its color when is added to reducing agent, its color changes from orange to green. The next very common oxidizing agent is chlorine. The half equation is Cl2 plus 2 electrons forms 2Cl minus. And when chlorine is added to reducing agent, its color changes from greenish yellow to colorless. Okay, during the reaction, oxygen molecules gain electrons and form O2 minus ions. 2Mg plus O2 forms 2MgO. Concentrated sulfuric acid, H2SO4, usually hot. When concentrated sulfuric acid acts as an oxidizing agent, sulfur dioxide is always produced. So you can see sulfur dioxide is produced when H2SO4 will behave like oxidizing agent. And the equation will be Cu plus H2SO4 forms CuSO4 plus 2H2O plus SO2. The next thing which we are going to read is concentrated nitric acid, HNO3, usually hot. When concentrated nitric acid acts as an oxidizing agent, nitrogen dioxide is produced. So this is another point to remember. Whenever nitric acid will behave as an oxidizing agent, NO2 will be produced. So the reaction is Cu plus 4HNO3 forms CuNO3 twice plus 2H2O plus 2NO2. You have to practice these reactions as maximum as possible. So there will be no much time in the paper to remember and write the equation. So practice a lot at your home in practicing these equations. Next topic which we are going to read is common reducing agents. The first common reducing agent is aqueous potassium iodide. Its half equation is 2I minus forms I2 plus 2 electrons, and when it is added to oxidizing agent, its color, potassium iodide colors, will change from colorless to brown. Next reducing agent is aqueous iron sulfate. Half equation is Fe2 plus forms Fe3 plus electron. So you have to practice a lot these half equations because these come in the paper. And when this reducing agent is added to oxidizing agent, its color will change from green to brown. Okay, hydrogen, C2H4 plus H2 forms C2H6. Hydrogen sulfide, when hydrogen sulfide acts as a reducing agent, sulfur is always produced. So sulfur is produced when hydrogen sulfide will act as a reducing agent. Equation is H2S plus Cl2 forms 2ACl plus S. Carbon, PbO plus carbon forms Pb plus CO. Carbon monoxide. When carbon monoxide acts as a reducing agent, carbon dioxide is produced. So this is the thing which you have to remember. When carbon monoxide will act as a reducing agent, carbon dioxide will be produced. So one oxygen atom will be added here. So it will form CO2 and Fe will be the other product. Metals, for example, iron acts as a reducing agent with copper 2 sulfate solution, and the equation will be Cu2 plus Fe forms Fe2 plus Cu. Okay, the next topic is substances which acts as both oxidizing and reducing agent. This is very important topic. This topic usually come in every session's paper. So concentrate yourself. Substances which act as both oxidizing and reducing agent. The first substance which we are going to read is sulfur dioxide. In the presence of water and hydrogen peroxide can act as both oxidizing and reducing agent. So here are some equations that will show how it acts as a oxidizing as well as reducing agent. So look now, sulfur dioxide in the presence of water forms sulfurous acid. When this acts as a reducing agent, it is oxidized to sulfuric acid. So look now, SO2 plus 2H2O plus Cl2 forms H2SO4 plus 2ACl. So in this case, it is acting as a reducing agent. Whereas in the presence of the hydrogen sulfide, a strong reducing agent, sulfur dioxide acts as an oxidizing agent. So look now, 2H2S plus SO2 forms 3S plus 2H2O. Okay, this is one example of the substance which is acting as a reducing as well as oxidizing agent. So here is another example, that is hydrogen peroxide can act as an oxidizing agent or a reducing agent. For example, with acidified potassium iodide solution containing ions, hydrogen peroxide acts as an oxidizing agent and oxidizes the iodide ions to iodine. And here is the equation, that is H2O2 plus 2H plus 2I minus forms 2H2O plus I2. With acidified potassium permanganate are stronger oxidizing agent then hydrogen peroxide. Hydrogen peroxide acts as a reducing agent. And here is the equation, that is 5H2O2 plus 2MnO4 minus plus 8H plus forms 5O2 plus 2Mn2 plus 8H2O. So hydrogen peroxide and sulfur dioxide are two very special substances which acts as oxidizing as well as reducing agents. So you have to learn these examples. Next topic which we are going to read is everyday redox reactions. The combustion of fuels in power stations in industry, in the home, and in transport, cars, aircraft involves redox reactions. So combustion of fuel actually involve reduction as well as oxidizing agent. So reactions, that's why these type of the reactions are called redox reactions. Okay, bushfires and accidental explosions are redox reactions. So this is another example. Copper plating, which you have learned in the top in another topic, is also an example of the redox reaction. The transfer of the copper atoms from a copper strip to an other object takes place when metallic copper and the object to be plated are placed in a solution of an appropriate electrolyte and are connected to the poles of the battery. Copper plating is an example of the redox reaction because oxidizing as well as reducing processes occur at the same time in this reaction. Redox reactions are also the basis of the large-scale production of the chemical ammonia, nitric acid and sulfuric acid needed for making fertilizers. The production of the materials needed for making plastics, insecticides and drugs often involve redox reactions. So these are some examples. Bleaching and yellowing of old books and newspapers are redox processes. So these are examples from everyday life that involves redox reaction. Iodine stains on cotton cloth can be removed by rubbing the stain with moist tablet of vitamin C. The brown color of the iodine is removed by moist vitamin C. So this is another example from the everyday life. Vitamin C is oxidized very easily and so it makes a good reducing agent. Here is an exam tip for you students is oxidizing agents get reduced while reducing agents get oxidized. So this is the reverse thing. Oxidizing agents gets reduced and reducing agents gets oxidized. Chlorine is a strong oxidizing agent in many chemical reactions. Oxidation occurs when there is an increase in the oxidation state and reduction occurs when there is a decrease in the oxidation state. Here is another question. In which pair is the underlined element in the same oxidation state in both compounds? So look now. In A part, both chloride ions have an oxidation state of -1 because you can see here the detail is here in option B. So H2 is having oxidation state of +1, that's why S will have oxidation state of -2, whereas oxidation state of O2 will be -4, that's why S will have +4. So these are having different oxidation state. Likewise in C part, the oxidation state of the iron will be +3 and +2. So in B part, again look, the oxidation state of O2 will be -4. So that's why Mn will have oxidation state of +4. Whereas in MnCl2, oxidation state of Cl2 will be -2. That's why oxidation state of Mn will be +2. So this is the explanation. Here is another question. In which reaction does a dilute sulfuric acid acts as an oxidizing agent? So in first part A, zinc is oxidized. If you can see, zinc is oxidized from 0 to +2 oxidation state. Hydrogen is reduced from +1 oxidation state to 0. So this is the reason. That's why in this A part is sulfuric acid acts as a reducing agent. The exam tip is sulfuric acid is an oxidizing agent that is reduced at the end of the reaction to hydrogen. Okay, another question is here. Solution X turns acidified potassium dichromate from orange to green. Okay, what must solution X contain? So it must be a reducing agent. That's why the potassium dichromate will turn color from orange to green. So this is the point which we have read in the concepts. So that is the point. Solution X must be a reducing agent. So solution X must contain a reducing agent to turn potassium dichromate from orange to green. Exam tip for you student is solution X has reduced the orange Cr2O7 to minus ions in acidified potassium dichromate to form green Cr3 plus ions. Okay, here is another question. Samples of polluted air are passed through two reagents, acidified potassium dichromate and aqueous potassium iodide. Which color change will be seen if the polluted air contains sulfur dioxide? Okay, very important part. So look now, these are the samples to reagents through which polluted air has passed. So the answer will be D, from orange to green, and no change. Look now, here is the explanation. With acidified potassium dichromate, sulfur dioxide is oxidized and Cr2O72 minus gets reduced to Cr3 plus and is changed from orange to green. There is no change with aqueous potassium iodide. Exam tip is there is no reaction with potassium iodide as it is a reducing agent.